Okay, in this video we're going to be talking about the areas of triangles, trapezoids, and rhombi. And in particular we're going to derive or come up with the formulas for each of these three figures. We're going to start with the triangle. And the area of a triangle, the formula for the area of a triangle is actually based on the formula for the area of a rectangle. Now, as we all remember, the area of a rectangle is just, say, area rectangle is just equal to base times height. Well, if I draw a diagonal on this rectangle here, then essentially what that does is that cuts this rectangle into two triangles. In fact, it cuts it into two congruent triangles. I know they're congruent because the height of this triangle here is the same as the height of this triangle over here. The base of this triangle is the same as the base of this triangle. And this third side here, since by the reflexive property it's congruent to itself, so I have side, side, side. I can use my side, side, side congruence postulate to show that these two triangles are congruent. Since they're congruent, their areas must be the same, which means that the area of a triangle is just equal to 1/2 of the area of a rectangle, which means 1/2 base times height. And that's a formula that many of you may already be familiar with, and that's where it comes from. You start with a rectangle, you draw that diagonal, cuts it in half. The area of a triangle is 1/2 base times height. So we just derived the formula for a triangle. Well, now we're going to do the same thing for a trapezoid and a rhombus. Okay, so the area of a trapezoid. What I want to do is I'm going to take this trapezoid and I'm going to divide it into two triangles, and then I'm going to use what I know about the areas of triangles to come up with the area of the trapezoid. So let me draw this line here that cuts my trapezoid into two triangles. And I'm going to note that the height of both of my triangles is right here. In fact, let me call this H. Call this side here H. And in fact, let me call this B1 and B2 for base 1 and base 2. All right, so these are the two bases of my trapezoid, and this is the height of my trapezoid. All right. Notice that this height, the height of my trapezoid, it's also the height of this triangle. Let me call this triangle number 1, and this is triangle number 2. And you can see the height of triangle number 2 is the same as the height of the trapezoid. It may not be as easy to see that the height of triangle number 1 is also the same as the height of the trapezoid. But let's break these triangles out, and I think that'll be a little bit clearer. So triangle number 1, let me draw that over here. Triangle number 1 looks like that. That's triangle URS. All right. So here's triangle number 1. And the base of this triangle, I'm going to call this the base of triangle number 1. I'm going to use this as my base. And I want to draw an altitude on this triangle. I want to draw it from, let's say, this vertex perpendicular to my opposite side. That's the definition of an altitude. Well, if I draw it perpendicular to the opposite side, it means I need to extend this over here. Drop that altitude. So here's the altitude of triangle number 1. Well, notice it's the same as this altitude here, which I've already called H. So H is the height or the altitude of triangle number 1. Well, that means the area of triangle number 1, I already know it's 1/2 base times height. My base is B1, the length of that base of my trapezoid. My height is H. So now I know the area of this triangle, that is this triangle right here on my trapezoid. Well, if I can find the area of this triangle, then I can just add them together and that'll give me the area for my trapezoid. So let me take the second triangle, let me break it down over here. Let's see. So this is my triangle number 2, and it has a base of length B2, and its height is just the same as this height here, the height of my trapezoid. Well, it's not hard to see the area of triangle number 2 is going to be 1/2 base times height. So area of triangle number 2, 1/2 base times height. The base of this triangle is B2, that is the length of my second base of my trapezoid. The height of this triangle is the same as the height of the trapezoid. Now I know the area of triangle number 2. Well, if I just add those two areas together, then I have the area of my trapezoid. So area of trapezoid equals area of triangle number 1 plus area of triangle number 2, which is 1/2 base 1 times height plus 1/2 base 2 times height. Now I'm going to rewrite this in a slightly different form. Notice that I've got a common factor of 1/2 in each of these two terms, and I've got a common factor of h in each of these two terms. I'm going to factor those out. So I'm going to write my formula like this. The area of a trapezoid is 1/2 height times base 1 plus base 2. And notice, if I use my distributive property here, then I multiply 1/2 h times b1, that gives me this term. 1/2 h times b2, that gives me this term. So I would just get back to that same form there. And this is the standard formula for the area of a trapezoid. And once again, we see we have just derived the formula for the area of a trapezoid. Now we're going to do the same thing. We're going to derive the formula for the area of a rhombus. So a rhombus, once again, I've got a drawing of a rhombus here, and I've also drawn in the two diagonals of a rhombus. And remember, the diagonals of a rhombus are always perpendicular. So I made my little perpendicular symbol here. And I'm going to also find the formula for the area of a rhombus by coming up with the areas of these two triangles here. In fact, this triangle here that's on top, this triangle that's here on the bottom, and I'm going to break those out in just a minute. First, I'm also going to need to label the lengths of my two diagonals. So let me call this long diagonal here. I'm going to call this diagonal number 1. And I'm going to call this short diagonal here, I'm going to call this diagonal number 2. All right. So now let me go ahead and break out these two triangles over here. So my first one, there's that triangle. And there's that triangle. So here's triangle number 1, this one on top, call that triangle number 1. Actually, I want to put that right there. Call this triangle number 1. And this is triangle number 2. All right, so triangle number 1, the top triangle, triangle number 2, the bottom triangle. Well, notice that if I draw in this piece of diagonal 2 here in these triangles, that's already perpendicular right here. So I'm going to use this as my height. In other words, the height of this triangle right here is going to be half of diagonal 2. So this is 1/2 d2. And also for this triangle, I'm going to use this as my altitude in this bottom triangle. Well, this is again 1/2 of this second diagonal. So that's 1/2 d2, 1/2 d2. Well, here's the base that I want to use for this triangle. What's the length of this base? Well, I can see the length of that base. It's the same as this long diagonal, the one I've called D1 in my rhombus. So this base here is D1. That's that base. This base here, I'm going to use this as the base for my second triangle. That base is also that same length. It's D1. So put that up here. Well, now I have the base and the height for this triangle. I have the base and the height for this triangle. I can say the area of triangle number 1 is, once again, the area of a triangle is 1/2 base times height. So 1/2 base is D1, times height. The height of this triangle is 1/2 d2. So let me say 1/2 d2. The area of triangle number 2 is also 1/2 base times height, 1/2. My base is d1. My height is 1/2 d2. And I can see that the area of triangle number 1 and the area of triangle number 2 are exactly the same. 1/2 diagonal 1 times 1/2 diagonal 2. Area of triangle 2, 1/2 diagonal 1 times 1/2 diagonal 2. The area of my rhombus is just the sum of these two areas, these two triangles. So area of rhombus equals area triangle 1 plus area triangle 2, which is, and let me go ahead and multiply my two 1/2s together just to get one number. So that's going to be 1/4 diagonal 1 times diagonal 2 plus the area of, that should say triangle number 2. The area of triangle number 2, again, that's 1/4 diagonal 1 times diagonal 2. So I've got 1/4 diagonal 1 times diagonal 2 plus 1/4 diagonal 1 times diagonal 2. And if I just add these two terms together, which I can do because they both have the same variables here, 1/4 plus 1/4, that gives me 1/2 diagonal 1 times diagonal 2. And once again, I have just derived the formula for the area of a rhombus. The area of a rhombus is equal to 1/2 the length of diagonal 1 times the length of diagonal 2. Now, what you're going to do in the rest of the notes, you have several problems where you're actually given some triangles and some trapezoids and some rhombuses. You're given the measures of different parts of those figures, and you're asked to use the formulas that we just came up with to find the areas of those different figures. So I'm going to leave you to do the rest of those examples, and we'll take a look at those in class tomorrow.